This video is going to go through Preview Activity 5.3, which is going to help us to find antiderivatives of functions whose derivatives would be found taking the chain rule. So first off, we're just going to take chain rule just to remind us what it does. So number one here, if g of x is e to the 3x, g prime of x is e to the 3x times the derivative of the exponent times 3. So I'm going to go through the chain rule pretty quickly. If you need some review on the chain rule, there's other videos you can take a look at. H prime of x, we do the derivative of the outside. Derivative of sine is cosine of 5x plus 1 times the derivative of the inside, or times 5. P prime of x, we have an arctan. Arctan is going to be, the derivative is 1 over 1 plus, leave the inside alone, 2x the quantity squared times the derivative of the inside, which is 2. If we wanted, we could rewrite that as 2 over 1 plus 4x squared. Number 4 here, q of x, so q prime of x. Got our classic general power rule, so pull the exponent down, leave the inside alone, decrease the exponent by 1, and multiply by the derivative of the inside. If we wanted to, we could write that as negative 28 times 2 minus 7x cubed. Lastly, r of x, we have an exponential that does not have a base of e, so r prime of x. So it's still going to have itself in it, 4 minus 11x, but times now the natural log of 3, because the base is something other than e, times the derivative of the exponent, which is a negative 11. So we're going to use the chain rule to work these backwards. So I'm not going to completely leave all our work here. But now what we want to do is think about the antiderivatives of these functions. And remember what an antiderivative does. It reverses the process. So if we want the antiderivative of m of x, I'll call it capital M of x. Well, remember, the derivative has itself in it, so will the antiderivative. So it'll be e to the 3x. Now when we did the derivative, we multiplied by 3, so going the other direction, we're going to divide by 3 or multiply by a third. Or we could write that as e to the 3x over 3, that'd be fine. N of x, we want the antiderivative of cosine of 5x plus 1. Well, look at what we got here. Cosine of 5x plus 1 times 5 has an antiderivative of sine of 5x plus 1. The only difference here is we don't have the 5. So we can compensate for that by multiplying by a 1/5 or dividing by 5. So what capital N of x is going to be is 1/5 sine of 5x plus 1. Right? We're just reversing. With the chain rule, we had to multiply by 5. When we're undoing the chain rule, we have to divide by 5. This one's going to look pretty cool, actually. At first you see this, and it may not be really obvious what the antiderivative is, but look at what we got when we took the chain rule. We had 2 over 1 plus 4x squared was arctan of 2. So our capital S of x is going to be arctan of 2x. But now, if we did that derivative, we know that it gives us a 2 on top. This only has a 1 on top. So we have to only take 1/2 of that. So we can adjust a lot of these by just multiplying by a constant. We're going to generalize this in this section, but this is the idea behind what we're doing. Now here we have v of x is 2 minus 7x to the third. We want capital V of x. Well, notice when it was 2 minus 7x to the fourth, it had 2 minus 7x to the third in the derivative. So we know it's going to have 2 minus 7x to the fourth in the derivative. The only problem is there was an extra negative 28 over here. that was multiplied by, so we need to get rid of that, so we have to multiply by a negative 1 over 28. Lastly, 3 to the 4 minus 11x. To do its antiderivative, well, w of x is going to have itself in it, 3 to the 4 minus 11x, but look at what the derivative had in it. Remember, it's like we're going from here to here. We don't want to have the ln of 3 and negative 11 in there, so we can divide by negative 11 ln of 3. So that would be our way of undoing these. Now let's see if we can generalize and do some functions that we didn't have the antiderivative of. So if a of x is cosine of pi x, the antiderivative, capital A of x, well, the antiderivative of cosine is sine of pi x. If we were doing the chain rule, we'd multiply by pi. Since we're doing the antiderivative, we'll divide by pi. If we had to do the antiderivative of this function, we know that it's going to increase the exponent by 1. But we also know that we'd be having to drop that 12 down to do the derivative. So we need to divide that by 12. Also, if we were doing the derivative, we'd have to multiply by a 1/4, or multiply by 4 because of the derivative of the inside. So going in the reverse, we'll have to multiply by a 1/4. And if we wanted, we could write that as 4x plus 7 to the 12th over 48. Lastly, capital C of x. Well, you can kind of work this one as, well, what about if it had an e to the x squared in it? I know it has to have that in it. And now if I was doing the derivative here, the derivative would be e to the x squared times the derivative of the exponent. So if I were looking at capital C prime of x, it would be e to the x squared times the derivative of the exponent, so times 2x. Well, that's just 1/2 too much, so I'm going to multiply that guy by a half.